I'm going to show you how to create models. So in projects and applications, we have these things called models. They are used to represent things. So in our social app that we're building, we'll have models that represent things like an article or a person or a newsfeed item or a post that they've created. So it's pretty simple to create those. And in this first part, we're just going to show you the basics of how you would typically create a model. And then in the second part, we will cover and show you exactly how to do that in our social app. So to get started, I just created a brand new empty project here. And the first thing that you typically will do when you create a project is when you create a model is you'll create a new file. So we'll do Command N. This will be a new Swift file. Now the name of the file is usually something that represents the model that you're going to create. So if we're going to create a model that represents a user, the file name, I want it to be user, and it will automatically put the .swift at the end since this is a Swift file. So here we have this empty file, and all we're going to do is create a struct in here. And we're going to give it the same name as our file name here. And then for our fields, this is where you would list out everything you'd like to list about the model object or the thing that you're representing. So if it's a user, we might have things like an ID or a name or a push token. We also might have things that are called who audit fields. So who last updated this object or this user, when did they do it, who created it, when did they create it. Those types of fields are very helpful for auditing purposes. So the way we do that, and you can use variables or constants here. It just depends on how you're going to end up using it in your project. We're going to say most of these are just going to be variables for our use case. So ID is usually something you're going to have across all of your objects. Sometimes you might even have a protocol which describes what every single object or every single model object in your project should have. And we'll show you how to do that again in the social app. And then each of these conforms to that. So it's a good idea to have an ID, something that uniquely identifies this user. And then we might have a name, and we might have a push token. And you'll notice that I'm making some of these optional. In fact, I'll make them all optional, which means they're not required properties in order for us to have a user. And then we might have a last updated. Now this is going to be you could do a time interval. I'm just going to do a double. It's the same thing as a time interval. And we're going to say last updated by, and this will be a string because our ID values are strings. And then we're going to have a created, which will be a double, and a created by, which will also be a string. Now you'll notice that these are also non-optional because those are required fields that we have to have on every user in our system. So that's the basics of it. That's basically all you have to do to create a model object. Now in part 2 of this video, or later on, we're going to show you exactly how to then take this basic model object and add some more cool things to it so that we can actually use it in a production app. Part 2, we're going to be talking about how to get a model created here to represent all of our posts that get created. So these are our posts. This is how our app looks right now. And we're going to create an object that represents every single one of these. So to get started, we're going to need to make some changes. So not only are we going to be creating a model object, we're also going to start to get things set up for our database integration and implementation. So to do that, we're going to come over here we're going to create a new folder or a new group here without a folder. Sorry, just a new group. And we're going to name this one database. So then we're going to hit Command N. We're going to create a new Swift file called database. This is going to be how we access our database. And we'll fill this out here in a minute. Now let's go ahead and create our model object. We're gonna have a couple of them. So the first one, let's create one for a user. And the next one, let's create one called a user post. Well, let's change this to be just a post. Okay, so now we have a couple of different files here that can represent our objects, and we're going to have a database. Now, I have another project that I've already done a lot of work similar to this on, and I'll be flipping back and forth and then explaining how some of these things work. So the first thing that we'll do is in our database, we have a couple of things here that I'm just going to bring over here, and then we'll talk about them. So this first one right here is called a collection name. This is just an enum. I call it collection name, and it conforms to a string type. The reason that we do that is because we're using Firebase's Firestore product for our database, and instead of being tables, they're called collections. So this will be the name of those collections in Firebase. And then down here we have a protocol that's been defined, and I'm going to change the name of this, so it's going to be SMA object. So this is just kind of a generic object type, a generic model type that conforms to Codable. Now, the reason I called it SMA object, you can call it whatever you want. I did it because our project name is called Social Media App, so this is a social media app object. It doesn't really matter what you call this, but that's what I called it. Codable. So this makes it very easy for us to use Apple's built-in methods for encoding and decoding JSON that map directly to our models. Super handy, super useful, and that's why this protocol conforms to it. And what we'll end up doing is we'll have each of our model objects conform to this protocol. So you can see the required variables for this protocol. We have a collection name, so which collection it belongs to. We'll have an ID so that it can be easily identified. And then we have all of our WhoAudit fields, created, created by, last updated, and last updated by. Then we also have this archived and archived at. So if you want to archive an object and be able to filter things out, you'll also have that ability as well. Now with those things created, let's go ahead and create our user object here, or our user model. Again, I'm just going to come over here and grab some stuff so that it makes it a little bit faster, and then we'll explain how this works. So we have our user here. This is going to conform to SMA object. We have our collection name. It has its ID, which is its required field. We have an APNS token. So on iOS, we have something called a token, push notification, or a push token. I call it APNS token so I can store it on the user object. They'll have a name, an email, and a profile image URL. And these are some other things that I had pulled over from the other app. We're going to get rid of them. And a role. So I do think we're going to want some type of role. So let's create that now. So this is going to be an enum that we can define down here. It will conform to a string type. And for now, let's just have a user role type. So just a plain old user. And it looks like we also need this to conform to Codable in order for this error to go away. There we go. So again, Codable makes it so that we can use it with Apple's built-in methods for encoding and decoding JSON, which is essential for passing it around on the internet. So now that we have this user set up, this model object here, let's go ahead and set up the rest of our database file. So we already have our collection name, our SMA object here. Next is we're going to actually set up our class for the database. This may not work because I think we need to include some things first. So yeah, I think it's gonna, yep, it threw an error here. So it can't find Firestore. That's because we don't have it included in our pod file. So let's do that now. All we need to do to include that is the pod Firebase Firestore. So in our pod file, right here, we're just going to add a new line for Firebase Firestore, and then in our terminal, let's get to where we need to here. We'll navigate into terminal to where our app is, down to where our pod file is, and you can see that we have our pod file here. And then we can just run pod install. This will take just a minute here. And it'll install all of the dependencies for that particular pod file. Or excuse me, this particular pod. Once that has finished, okay, I like to build the project, and I do that with Command B, and we'll come back here in our database file, and we're going to need to import that hasn't compiled yet, but we'll go ahead and type it out. So we'll import Firebase Firestore here. Yep. Once it finishes compiling, I think we'll see this warning go away. While that compiles, let's clean up this copy paste here for a minute. So we don't actually need the products. That was for, again, another project. And what I've done here, this is completely up to you, but Firebase does not index your data that's stored locally. So Firebase's Firestore product by default will actually store copies of your data locally on your device, which is great because it makes it fast for getting the information, and you may not always need an internet connection to be able to access the information. The downside is that when you're dealing with a lot of data, it's not indexed, which means it gets slow as your data grows. So I disable that. I say Firestore settings is persistence enabled equal to false, and then I set those settings on the database instance that I'm going to be using here, and we have a reference to that here. This is inside of a private initializer. This just gets called automatically when we called shared on this class. So I recommend doing that if you're thinking you might have a lot of data. It can really slow things down if you don't have that enabled. So we're just waiting for this to finish compiling here. While we're waiting for that, let's create our second object. So again, I'm gonna come over here and grab our, this is again one I'm just going to copy and paste for our post here. We'll change some things. So this will be a post, SMA object, and the collection name is post. So some things that we're going to want if we were looking at our application again here. Let's pull it up. It's not that one. Oh, right there. Social media app. Okay. So you can see we've got an image. So we'll want the image URL. We'll want the name. The comment count we'll definitely want. We don't have a like button, so we don't actually need those. The like count and the liked by. You can't bookmark it either, so we'll get rid of that. Now, these other posts here, these other things are kind of important. So in order to support moderation on the platform, this is just one way that I implemented that. I have a visible to public, so that controls whether or not the person who created the post can just see it themselves or if other people can see it. We can see if it was approved by a moderator or denied by a moderator, whether or not it has been moderated, and if it's been reported by anybody. So even if it passes moderation but other users report the post, we want to keep track of that as well so that we can look into it further. And then the post number. I do that for ordering purposes. You could also do it based off of the created. I guess it's just a preference thing if you want to have just a number that you can use to order your posts, or if you want to filter it down by created. So I have the post number there. You can have it if you want, but this is all the properties we need. So again, we just created a struct called post. It conforms to the SMA object. It has a collection name here for post, has our ID, and all of our properties that we need. All right, so it finished building, and it looks like the errors went away. So we can finish up this class. So there's a little bit more we have to do here. And I'm just gonna, again, copy and paste from this other project. It saves time. All right, let's take a look. So we're gonna need to change these errors out here, and then we'll walk through what this does. And it looks like we're missing the Firebase auth framework as well. So we'll want to import that up here. Okay, and we'll get to this error in a minute. So all that we've done here is we've added some helpers. So when you go to save one of your model objects, it calls this get document reference. So in here, we need to know the collection. So then it calls get collection. And inside of here, it says to get the collection of a type of SMA object, and it uses a collection name. So it calls this function and returns back this collection reference. So this is one of Firebase's built-in ways. This is how you query stuff and do things in Firebase's Firestore. So that's what it returns. So it uses that enum property on the object to get the name of the collection, so it can return that. And it returns it back to here, which returns that back to here. So we have a collection. Then we look and see if this particular object that we're trying to do something with has an ID already. If it does, we're just going to reference that specific document. If it does not, we're going to create a new document, which will create an auto-generated ID for us. That's important because everything that we do in Firebase Firestore, if it has an ID, we're going to want to use it. Otherwise, we'll end up with duplicated documents. We don't want that. So then in here, we are going to set our last updated and last updated by properties. And I use this time interval since 1970. It is based on UTC. So it can be used across different time zones without an issue. And it returns a time interval. And a time interval is just an alias of double. So yeah, you can see it's just a type alias of double. So it's really just a double. It's just a number with a decimal point. And that's where we're saving there. This is because we have not included another third-party framework and a couple of extensions. The reason we're getting this error here. So Firebase, by default, it doesn't just take a regular old JSON object, which can be problematic if you don't use this third-party library. So let's do that now. I will just come and grab it from this other project. It's called Codable Firebase. I've used it in several projects and it seems to work quite well. So we'll just add that to our pod file here, open up terminal, do a pod install, and that will install that pod for us. But that's not all we need to do. We'll need to create 2 new files that are extensions. So in here, we're going to create 2 new files, and I already have them in here. So the first one is going to be called encodable. Encodable, just like that. And then the second one that we're going to create is called document snapshot. So encodable, we're going to be extending Apple's encodable library. And I'm just going to copy everything in this file. And we're just going to replace everything in here. So it's not too important to understand necessarily what's going on here, but it's pretty simple. We're just grabbing this custom Firestore encoder from the framework of Codable Firebase, and we're trying to encode the data, and then we're also removing any keys that we really shouldn't be having here. The only one, because this is with Firebase, is we're going to remove the ID property. Whenever we save or update it, we don't want to actually have that property in with the rest of the data, because that's just not how Firebase works. Firebase has the ID 1 level higher than the rest of your JSON data. So that's basically all that this function does here. In document snapshot, we'll come over and grab that one. Oops. I'm not going to go over the details about what this one does. I would say suffice it to say that it's just needed in order for this to work. So this has to do with decoding the data and then adding the keys and stuff back where they go, so that it'll match to our objects in Swift. So that's what we need in order for that to work. If you need to pause the video so that you can write all this stuff down, you can do that, or I think I've included them in one of the Jira tickets. So back in our database, we'll see that the error went away. Looks good. And then we're using the set data and we're merging it if it does have existing data. So this allows us to create new documents, to update documents pretty seamlessly. So I think we're good there. I'm just going to build the project again and see what we've got. And this should be everything that we need in our database.swift file. Cool. The other thing that we're going to need to be able to do is in our, let's see, I think it's in our tab bar. Oh no, it's in our Splash controller. So in here, we'll eventually be updating this so that it will also handle and create a new user for us if we don't already have one. If we do already have one, then it will be updating that user with their first, last name, and email if these are present. These are optional, so if they're present, we'll update that. But that's about it. We're going to cover that in another video, actually hooking this up to Firestore. But that's all we need to do to get the project set up. We've got our database class that we're going to be able to use to save documents, and we have 2 new model objects that are enough for us to be able to get a user signed in and have that user account there, as well as providing a model object for a user's post when they create a post, so that they can have that reference to them when it's been created. In another video, we're gonna, like I said, we're gonna wire this up so that we'll have the user connected, and then we'll also have our posts connected. So we'll create a function that will call when you want to create a post or when you want to get posts from the database, and then we're going to need to create some sort of UI for a user to create their own posts. So yeah, that's what we're looking forward to. Hope this was helpful, and thanks for watching.